In example 5, we're asked to find the derivative of inverse trig functions, and the very first one that we're asked to look at is the arc sign, or the inverse sign. And so that is going to be given by u prime over the square root of 1 minus u squared. So we can begin with that formula. So dy dx is equal to u prime over the square root of 1 minus u squared. I like to go off to the side and collect these values. So u is equal to 5x, and then u prime is going to be 5 by the power rule, and u squared is going to be 25x squared. Now we can substitute into our formula, and we have dy dx is equal to 5 over the square root of 1 minus 25x squared. So this really is just plugging into the formula for the derivative. Why don't you take a moment, pause the video right now, and try to take the derivative of arctangent, inverse tangent. And then we'll come back and check in a moment. So we begin by just simply writing down the formula for arctangent, or the derivative of arctangent. So dy dx is going to be equal to u prime over 1 plus u squared. In this case, u is equal to the square root of 2x plus 1. And we will rewrite that using fractional exponents, 2x plus 1 to the 1/2 power, and that will make it easy for us to find u prime. Using the power rule, we get 1/2 times 2x plus 1 to the negative 1/2 times the derivative of the inside via the chain rule. We get 2, but the 1/2 and the 2 cancel, and u prime is equal to 1 over the square root of 2x plus 1. Finally, u squared is the square of the square root of 2x plus 1. So squaring a square root gives us back the radicand, the value that is inside the square root. Now, substituting in, we get u prime, which is 1 over the square root of 2x plus 1 divided by 1 plus u squared, which is 2x plus 1, and that's going to be 1 over the square root of 2x plus 1 over 2x plus 2, and finally that's going to give us 1 over the square root of 2x plus 1 times 2x plus 2, and that will be our derivative.